The next example that we want to look at is solving a system of nonlinear equations using elimination. So again, looking at our graphs here, we've got a linear function, the 3x minus y equals -2, so that's the one shown in red. And you've got the 2x squared minus y equals 0, which is our parabola in blue. So if we want to find a solution to the system of equations, really what we're looking for is where do they intersect? I've got an intersection point right there, and I've got an intersection point down here on the left. The one on the right there looks like it's about the coordinate 2, 8. And if I look at that other one, it looks like we're left 1/2 and up about 1/2 as well. So -1/2 and +1/2 if I'm estimating where those solutions are. Now our goal is to solve this algebraically to prove that those are the solutions. So if I'm using elimination, what I want to do is make sure that I can get rid of either the x values or the y values. So if I look at the two equations, I have an x in the first equation, I have an x squared in the second equation. Using elimination on the x probably isn't the best idea because they're different powers. But if I look at the y's, they're both first power of y. I just need to make one positive, one negative. So if I take this top equation and multiply it by -1, I can get a 3x that's negative now, plus y is equal to a +2. Then I'm just going to copy down the bottom equation as it was so that I can add these two together. Because if I add these two equations together now, a positive y and a negative y are going to add to 0. I can't combine the x's into a single term, but I can combine them into an expression on this left side, 2x squared minus 3x. And then if I add the 2 and the 0, I get a 2. Now, if I'm trying to solve this, when I've got an x squared, an x, and a number, I'm going to want to bring that +2 over to the left side with everything else, so that I have 2x squared minus 3x minus 2 is equal to 0. And now we can either use the quadratic formula, we can complete the square, we could solve by factoring, whichever method makes most sense to you at this point. I'm going to solve by factoring. So I got factors of 2 times -2, which is -4, that need to add up to -3. So I can split that up and say 2x squared minus 4x plus 1x minus 2, which allows me to group this. So I can pull out a 2x, and in doing that, I will have a x minus 2 left over. The second factor, I can only pull out a +1, and I'll have that x minus 2 left over. So my two factors here are that common x minus 2 that we had, and the two things we pulled out, which were the 2x plus 1. And these are still equal to 0 when multiplied. So then to find the solutions for x, I just need to find the zeros of each of those factors. So I can get x is equal to 2 off the first factor, and x is equal to -1/2 off the second factor. Now if I look back at my graph here, x is equal to 2 and x is equal to -1/2 are the x values that we had. So if I want to find the y's, I need to plug each of those x's back into one of our original equations. I'm going to choose to go with the 3x minus y equals -2. So if I come down here, we had an equation 3x minus y equals -2. And I'm going to substitute the x values in, but I'm going to do something first just to make this a little bit easier. I'm going to isolate the y and say 3x plus 2 is equal to y. So that when I substitute those values in, I don't have to do as much math to manipulate things. So if I substitute these in, got two different x's I'm plugging in. X is equal to 2, will give me 3 times 2 plus 2. So 6 plus 2 is equal to 8. So my y value on this one is 8. And then my second one, I had x is equal to negative 1/2, which would be 3 times the negative 1/2 plus 2. 3 times negative 1/2 is negative 1.5. And then if I add 2 to that, I end up getting y equals 1/2. So then my two coordinates that I have, I plugged in a positive 2. I got a positive 8. So that's one of my solutions. This one, we plugged in a negative 1/2, and we got a positive 1/2. So that would be my second solution. And if I look back up at my graph, those are the exact two coordinates here and here that we estimated based on where those two graphs intersected. So we can find those coordinates through graphing, but more commonly we're going to use the algebra and either substitution or elimination to figure out what those x's and y's are, and then put those together as ordered pairs for the solution to this system of equations.